we now kind of enter the second part of this module, you could say. Thus far, we had a thorough look at how we can send HTTP requests, how we can handle errors, how we can work with the data we get back if we don't have errors, and so on. Now let me dive into a little bit more advanced parts of the Angular HTTP client and how you can configure your requests and which kind of different responses you can back, and so on. Let's start with headers. When sending an HTTP request, and of course we are configuring our requests in the post service, so this is the place to look at now. So when configuring these HTTP requests, you set things like the URL you send the request to, or in the case of a post request, you also set the data you want to attach to your request. Now, of course, sometimes you also need to set some special headers. For example, when you have a backend that requires authorization and looks for an authorization header, or if you want to set your own content type, or you need to attach a custom header because your API you're sending the request to needs it. Now, setting your own headers is extremely simple. Any HTTP request method, no matter if it's post or get or delete or patch or whatever, any of these methods has an extra last argument. So in the case of get, it's the second argument. In the case of post, it would be the third argument, which is an object where you can configure that request. And there you can configure a bunch of stuff, as you can see. And we'll start with the headers here. And headers now takes a headers object, which allows you to set the headers you want to send. To be precise, it's a HTTP headers object, which you need to import from @Angular common HTTP. So you need to add this import at the top, and this allows you to create a new instance of this object with the new keyword. And to this object, you can pass a JavaScript object here with the object literal notation, where you can have key value pairs of your headers. And headers are, of course, key value pairs. So for example, here you could set your custom header, in case your API would need that, to hello, or whatever you need. You can set any header, any HTTP header pair here. And if I do this and I save that, and I now do try to fetch some posts, I fetch posts as before. But if we have a look at the network tab, let's actually do that again with the cleared network tab, and we have a look at our request here. If we inspect the headers, you see here on the request headers, there is this custom header hello, and that's that custom header I attached. And it's as simple as that. You can add as many headers as you want with this simple approach by simply setting the headers config option here to a new HTTP headers object to which you pass your headers in an object literal with a key value notation. Headers aren't the only thing you can set. For many API endpoints, you can also attach certain query parameters. And of course, again, it depends on the API endpoint you're sending the request to, which query parameters are supported. For example, the Firebase REST API, and you can learn that in the official docs, supports one query parameter, which effect we can immediately see. You set parameters by adding the params key here in that same config object where you added headers. And you set params equal to new HTTP params. Now, just as HTTP headers, you import HTTP params from @Angular/common/HTTP. Now, HTTP params works a bit differently than HTTP headers. There, you can call set, and now you can set a param name and a value for that. And there, for example, you can set print, and that is a search param, a query param supported by Firebase, print, and you set this to a value to pretty. And this just changes the format in which Firebase returns its data. Now, if we save that, this loads, and now if I clear that and I click this again, and we inspect this request, you see now it has this query parameter attached to the end of the URL. And of course, you could have added this to the URL yourself up there too. You could have added print equals pretty up there and add with an ampersand in between as many key value pairs as you need or as your API endpoint supports. You can do that here in the URL, but by using this params config, it's a bit more convenient because you don't need to concatenate a super long string. You simply set them here with the set method. Now, if you wanted to set multiple params, you can simply do this by adding a search params constant or whatever you want to name it. Create your new params object there. And now here, you can call search params append and append a new param key value pair like print pretty. Important, however, search params, this object is immutable. So you actually need to override this, and therefore this needs to be a variable, with the result of append. So what you would do here in the end is you call append, and this returns a new HTTP params object, and you store that new object, which has these new key value pairs added to it, in the search params variable, overwriting the old one. So you still have a HTTP params object in there, but a new one. And if you have multiple key value pairs, then you simply repeat that step. With append, the old ones will be kept, but the new ones will be added to a new HTTP params object, which will then replace the old one by storing it in that same variable. So here you could also have your custom key, which is not supported by Firebase, but you can still send this. It won't cause any harm. And then you simply add your search params here for the params in your config object, and this is how you can attach multiple params if you want to. We can see the effect here. If I fetch, now you see we have multiple search parameters attached. Again, you could have done that directly in the URL, but by using the HTTP params object and the configuration object, it's a bit more convenient. Now, by the way, in case you're wondering what these parameters do, custom key does nothing. That's just something I came up with. It's not supported by Firebase, but as I mentioned, it's also no problem if we add this. Print pretty does something in the response. It prints this in a more pretty way. It adds some extra white space and line breaks so that this is more human readable. Absolutely does not matter for our app, where we read this with our code anyways, but I just wanted some example to show how to add query parameters. Thus far, we always were only interested in the response data of our request, right? For example, when we fetch the posts, we get the response data, we map that, and we return the subscription, and then we use that data in the component. Nothing wrong with that, and absolutely what we need here. But sometimes you need access to the entire response object and not just to the extracted body data. Sometimes you need to find out which status code was attached, or you need some response headers. And in such cases, you can change the way the Angular HTTP client parses that response, and you can basically tell Angular, hey, please don't give me the unpacked, the extracted response data you found in the body, give me the full response instead. And let's do that for sending a post request, for example. You do that by adding this extra argument to configure the request. And here I won't set any headers or params. Instead here, we can change the observe key here. Observe takes a couple of values, and IntelliSense here incorrectly shows that I can only set body. That actually is the default. And body means that you get that response data extracted and converted to a JavaScript object automatically. But you don't have to stick to body. You can, for example, also change this to response. By the way, you should get an error if you enter something incorrect, but response is supported. Now, let's see what this is. We are already logging the response data or whatever we get back here in the console, so we should see that when we add a new post. So let's simply enter some content here, doesn't matter, and let's send that post. And now you see you get back the full HTTP response object. You have the body in there, and conveniently, this still already was parsed and converted to a JavaScript object for you. But if you wanted to access it, you would now have to access it by typing response data body here. And you even get auto-completion because TypeScript understands that we request the full response here. So you still have access to that body, but now you also have access to the headers of the response, to the status code, the status text, if it was okay, which will be true if the status code is in the 200XX region, so if it's not a 400 or 500 status code. And that can be more useful in some scenarios where you maybe don't care about the body, or not only about the body, but you actually want more information than just that. With Observe, you can change the kind of data you get back. Now, this is how you observe the response. You can also observe something different. So here, when we delete posts, I will use Observe again. And I mentioned that body would be the default, and that extracts the response body and converts it to JavaScript. You also have response, as you learned. Now you also have events. Now what is events? Let's simply have a look at this events thing by using one other operator, which we can chain in here. And we import that from RxJS operators, and that's the tap operator. And that simply allows us to execute some code without altering the response, so that we basically just can do something with the response, but not disturb our subscribe function and the functions we passed as arguments to subscribe. So here I simply pipe tap in there. I get my event, presumably, since we observe events here. And I can console log this, and you don't need to return anything or anything like that. It won't interrupt the normal observable data flow. It just taps in there, allows you to do something, but then automatically lets the response pass through, so to say. So let's see what that gives us. If I now click clear posts, we see we get two outputs now. And these outputs stem from posts service line 70, which clearly is this console log. So it seems like we got two events here. The first one logs an empty object, or an almost empty object, where we have type 0. And the second one is the HTTP response object. In the end, you have different type of events, and they are encoded with numbers. However, here in code, you don't have to use these numbers. You have a more convenient way. We can check event type and compare this to HTTP event type, which is an enum you can import from @angular/comment/HTTP. This is supported in TypeScript only, and for JavaScript, this in the end just is a map of numbers, so of 0 and so on, and it understands which type of event, so which number here stands for which internal type of event. But here we have a more human-readable way, because now if you type a dot here, you see the different translations. Now these are just the responses for the numbers you see in that log here. And you can actually see that here in the preview. You see, for example, response has a type of 4 by the look of it. This is simply number 4 encoded in more human-readable text. And again, that's a TypeScript-only feature. It is compiled to just that number comparison in the end. And you see that, for example, send has that number of 0. So it looks like we had the send event first, and then we had the response event, and that was also logged. There are other events too, which didn't kick in here. For example, when you're uploading files, you would get back some progress information about that file upload, how it is going, and so on. So here, if you ever, for example, want to check, did I get back the response? Then you can just compare the event type to this event type, so to this number, and see, are we having the response here? And if you do have the response, for example, you could log the event body, because you know, okay, the event we have here is actually my response object. I can safely access the body. If you just send this, so if the type is equal to HTTP event type send, well then, and the TypeScript is really smart here, then you can't access the body. Here you actually have only the type, but you could do something else. You could update something in the UI to basically inform the user that the request was now sent and you're waiting for the response. So that is how you can use these events if you need very granular control over how you update the UI and how and in which phase your request currently is. So to quickly demonstrate this again, if I now fetch my posts, and I now clear them, now we have our different outputs here, and this null statement here, for example, is from me accessing the response body, which here just happens to be null, but if there were one, then we could safely access it here. So these are events, obviously something you'll not use all the time, but can be very helpful if you need fine-grained control over your request status.